What if your strongest employee is making your weakest process look healthy?
Mm-hmm.
It's a question that kind of lingers, isn't it?
Yeah, it really does.
Because it's a paradox that plays out every single day.
Yeah.
You see it on factory floors, in hospital wards, on construction sites.
Everywhere.
Right. We are so conditioned to look for failure in the metrics that turn red. The glaring
The
errors.
alarms.
Exactly. But today, our mission on this deep dive is to explore how exceptional individual performance might actually be, well, the most dangerous cloaking device your organization has. We are examining what's called the best operators paradox.
Yeah, and it's a fascinating lens because it forces us to really re-examine what success actually looks like on just a random Tuesday afternoon.
Right.
We tend to assume that a smooth operation is the result of a brilliant system,
Sure.
but often the most critical systemic failures, they're hidden right in plain sight. They're masked entirely by metrics that are just consistently, reassuringly green.
Reassuringly green. I like that. But, if the dashboard is entirely green, how are leaders missing the friction? Because that is where leadership usually starts their day, right? The dashboard. We look at output, we look at targets, throughput, delivery dates. These are the standard boardroom metrics, and they are incredibly seductive because they're binary.
Yes.
We shipped the units or we didn't. The patient was treated or they weren't.
Yeah, they offer this illusion of precision. Dashboards tell us exactly what happened,
Yeah.
but they are remarkably silent on how it happened.
Right, the journey to get there.
Exactly.
Yeah.
Almost none of these standard metrics reveal the friction. They don't show the sheer manual effort or the rapid, unrecorded interventions that were entirely necessary to force that green light to turn on.
To force it on. Yeah, and that gap, that's what ergonomists and systems researchers like Stephen Shorrock and Eric Holnigal, they call that the difference between work as imagined and work as done.
Yes, a crucial distinction.
Because work as imagined, that's the pristine, frictionless process that's written in the standard operating procedure. It's the flow chart on the manager's wall. And in that world, nobody forgets a step, the equipment always works perfectly, and the environment is just entirely predictable.
Right. It's a sterile environment. And then you step into the real world.
Yeah.
Work as done is the direct, lived experience of the people who are actually executing the task. And it is inherently messy.
Always.
A context is always shifting. Priorities compete, equipment degrades, or, information is delayed or it's just missing entirely.
Right.
And the gap between those two realities, it is bridged almost entirely by human adaptation.
It really feels like a direct evolution, or I guess maybe a direct failure, of that old Taylorist view of management.
Oh, totally.
Frederick Winslow Taylor's scientific management from the early 20th century.
Yeah.
He essentially broke work down into the absolute smallest possible technical components.
Right, with a stopwatch.
Exactly. The assumption was that if you just prescribe the exact physical movements, a worker will function flawlessly, like a gear in a machine.
Yeah, but Taylorism fundamentally ignores the human factor.
Right.
It ignores the shifting context of the actual environment. It assumes a completely static reality. And it's interesting because even Taiichi Ono, the co-creator of the Toyota production system, he once fell into this exact trap.
Oh, really?
Yeah, he insisted early on that operators run multiple machines simultaneously to maximize efficiency. And this was strictly based on his work as imagined.
Okay.
But he hadn't actually tried to do it himself to see the cognitive and physical load it required. So performance and morale just plummeted because the prescription was fundamentally detached from reality.
Wow. Yeah, and there's actually a fascinating demonstration of what happens when workers strictly adhere to work as imagined.
Oh, malicious compliance.
Exactly. Malicious compliance or working to rule. Take the case of a Renfe train driver in Spain. He simply stopped his train at a station and abandoned it, leaving all the passengers completely stranded.
Just walked away.
Just walked away. Because according to the exact official rules regarding his duty time limit, he was finished.
Right.
And the company argued he should have used, quote, common sense.
Right.
But demanding common sense is essentially an admission that the official rules are broken.
Yeah.
And the organization is relying on the driver to constantly quietly violate them just to keep the system running.
Yeah, it's a huge contradiction. Let me push back a bit, though, with a grounding question that I think a lot of leaders might ask when they hear about the train driver or any operator bending the rules.
Sure.
If the dashboard is green and the targets are ultimately met, why should leadership actually care how the team got there. I mean, isn't the point just to get the job done?
Right. It's the ultimate pragmatist's argument. If it works, it works.
It is pragmatism, yeah, but it is incredibly short-sighted. Because here is the operational reality. When management only sees the final result, they become entirely blind to the true fragility of the system.
Oh, I see.
If your green dashboard is the result of a robust, well-designed process, then you have resilience. But if that green dashboard is only achieved because an operator is constantly improvising, overriding alarms, borrowing parts to bypass broken steps.
Right, running around putting out fires.
Exactly. You do not have a resilient system. You have a highly fragile system that is being manually held together. And the moment that specific operator is absent, or the moment the environmental stress exceeds their personal capacity to adapt, the system doesn't just slow down, it shatters.
It shatters. Wow, so we're talking about an invisible economy here.
Yes.
Like a shadow economy of manual labor that exists purely to bridge the gap between broken processes and successful outcomes.
It is the invisible recovery economy, and it operates entirely off the books.
So what did the mechanics of this shadow economy actually look like? On the ground, I mean.
Yeah. Well, on the ground, this looks like informal workarounds, manual corrections, hidden interventions.
Right.
It's the knowledge of how to actually get a specific machine to run, like the fact that you have to tap the gauge twice before you pull the lever.
Oh, right.
That knowledge is held purely in the mind of one senior machinist. It's not documented in any manual.
To really understand the mechanics here, I feel like we have to look at organizational learning. Specifically, Chris Argyris's differentiation between single loop and double loop learning.
Yes, perfect framework for this.
Because what we are seeing in this invisible economy is almost exclusively first-order problem solving, which is pure single loop learning.
Exactly. They are treating the immediate symptom, but leaving the disease entirely untouched.
Right.
An operator bypasses a broken tool, production continues, and the system never logs a failure.
So it's like the operator encounters a block, a missing supply or a software glitch or maybe a poorly calibrated tool, and they invent a workaround to fix that immediate block so production can keep moving.
Right.
They get the job done. But the underlying process flaw remains completely uncorrected.
Yeah.
And because the workaround succeeded, the system doesn't register a failure at all.
It just sees green.
Right. So the double loop learning, which involves actually stepping back, questioning the underlying assumptions, and redesigning the flawed process, that never happens.
Never happens. And that workaround isn't free.
No.
EPRI recently analyzed what they call operator burden, and they found that these informal interventions, they silently consume the operator's mental and physical bandwidth.
Operator burden. That's a heavy term.
It is. It's the aggregate toll of constantly having to respond to undesirable conditions. Conditions that really should be controlled by fully operable systems.
So it reduces the operator's capacity to do their actual job, like conducting proper inspections or quality control.
Exactly. And more terrifyingly, it reduces their ability to respond to an actual emergency. Yeah, because their cognitive load is already maxed out just keeping normal operations afloat. So during a high-stress event, an operator might completely forget about a complex, unofficial workaround they implemented, say, 3 hours ago.
Right, because they're juggling too much.
Yeah, and that leads to cascading failures.
To visualize this, I was reading through some of the source material, and there was this visual metaphor that really stuck with me.
Okay.
Imagine a massive, complex industrial system, and it is visibly operating at absolute maximum effort. You have multiple compressors running, additional standby units are fully engaged, control valves are actively compensating, pressure regulation is visibly working hard. The entire facility is just redlining.
Right. Roaring.
Yeah, roaring. Everything appears fully committed to solving a massive problem. But then you pull the camera back farther and farther, and you discover the actual cause occupies less than 1% of the footprint. It's a single, tiny, obstructed branch line, perhaps just a lightly neglected component. The system looks highly functional, it's handling the load, but the scale of compensation required for that one tiny failure is astronomical.
That is a perfect metaphor. If we map that industrial metaphor onto human capital, it completely explains this invisible recovery economy.
Right.
Often, an entire operational team is silently redlining. They are compensating, escalating their efforts, burning through their personal reserves.
Just to keep it going.
Just to keep it going, all to work around one missing piece of information or one awkward sequence or maybe one unclear handover between departments.
Wow.
The effort is massive, but because the output remains steady, leadership only sees the compressors running smoothly. They don't see the tiny obstruction that's causing the entire human system to work twice as hard.
And this leads us to what feels like a really profound vulnerability.
Yeah.
The better the operator becomes at their job, the less visible that underlying problem appears.
Exactly.
This is the paradox of expertise.
It really is.
I was reading Scott Snook's analysis of the tragic friendly fire shoot-down of 2 U.S. Black Hawk helicopters in Iraq. And he used this phrase, procedural drift.
Yes. Snook's work is critical here.
But how does a military tragedy like that map to what we see on a standard Tuesday in a hospital or a factory?
Well, Snook defines procedural drift, or practical drift, as the natural, uncoordinated divergence of daily operational execution from the formal written procedures.
Okay.
It happens gradually, and it's usually in response to real-world pressures like time constraints, resource limitations, or even just contradictory rules.
Right.
So in a hospital, it might be skipping a secondary sign-off on a medication because the attending physician is in surgery and the patient needs the pain relief right now.
Right. You're trying to help the patient, so you drift from the procedure.
Exactly.
And it maps directly to Diane Vaughn's analysis of the Challenger space shuttle disaster.
Oh, yes.
She identified the normalization of deviance. It's this gradual, insidious process through which unacceptable practices, or deviations from safety standards, they slowly become the accepted social norm within an organization.
And the mechanism behind how this deviance becomes normal is crucial to understand.
Right.
Why does it feel safe to the operator? Because the deviant behavior is repeated over and over without a catastrophic result.
Right. Nothing blew up yesterday, so it must be fine today.
Exactly.
Mhm.
Every time an operator bypasses a broken rule or skips a cumbersome safety check and the system doesn't immediately fail, that choice is validated. It becomes locally rational.
Locally rational, yeah.
The perceived risk of the workaround is discounted to almost zero because historically, it has always worked.
You know, the Costa Concordia cruise ship disaster is a terrifying example of exactly how this mechanism plays out.
It really is.
Because the captain deliberately strayed from the official route to perform a salute close to the island of Giglio. And that resulted in the ship capsizing and 32 lives lost. But if you look at the investigation, this wasn't an isolated road decision made in a total vacuum.
Right.
Over the course of the season, the command structure had normalized these route deviations.
They knew about it.
The leadership not only tolerated but actually promoted these risky ship salutes because they were a highly effective, convenient marketing tool for the passengers on the shore and on the ship.
Yeah.
The deviation had been completely normalized by past success. They literally drifted into failure.
They did. But we do need to explore this carefully, though.
Sure.
We must avoid overstatement or universal claims here. Drift does not always equal disaster.
Okay.
In many complex, dynamic systems, procedural drift is literally the only way work gets done. Fully optimizing a complex system, making it perfectly rigid, is actually undesirable because it removes the slack needed to absorb unexpected shocks.
Let me play devil's advocate for a second.
Go for it.
It sounds a bit like we're blaming the operator. Like we're saying they are breaking the rules, they are the ones drifting, they are the ones creating the organizational risk. But aren't they just trying to survive a bad system?
That is a vital distinction, and I'm glad you brought it up. This is not malicious rule breaking. In almost every case, it is a highly predictable response to production pressure, resource scarcity, and poorly designed procedures.
Right.
The operator is caught in a bind, follow the rigid rule and fail the production target, or adapt the rule and succeed.
And they want to succeed.
Exactly. By adapting, the operator is actually preventing the problem from causing a failure. They are the protective structure. But in being so, they make the malfunctioning of the broader organization completely opaque.
Wow. So they absorb the friction so the system doesn't have to.
Yes. There are workarounds that have been temporary for so long, they now qualify as infrastructure.
And occasionally they arrive with documentation years later.
Some organizations have critical process knowledge.
It's usually stored in a person.
Yeah. If the knowledge is stored in a person and the friction is hidden from the dashboard, how do leaders actually find it? I mean, how do you diagnose this invisible economy without breaking it?
Right, because if you shine a light on it the wrong way, everyone just scatters. But there is a practical, unvalidated inspection framework called the Recovery Load Review.
Huh?
It is a fundamental shift in observational focus. Instead of measuring the output, you measure the interventions required to achieve the output.
Oh, that's smart. The diagnostic asks leaders to look for very specific signals. You identify tasks that require frequent intervention.
Hmm.
You look at the performance variation between highly experienced operators and newer ones. Because if a process only runs smoothly for 20-year veterans, the process itself is likely flawed.
Right. It relies on their tribal knowledge.
Exactly. You record manual corrections, overrides, exceptions handled, and moments where someone had to ask for clarification because the standard procedure was just ambiguous.
The suggested action here is to spend 30 minutes, just one operational cycle, observing a top performer. And the instruction is strict. Do not evaluate their output.
Yes.
Simply count the recoveries. Count every time they have to adjust a machine that should be automatic, every time they have to chase down missing information, every time they interpret a vague instruction.
Yeah.
But wait, in a hyper-optimized warehouse, where every second is tracked by algorithmic management, how does a middle manager justify spending 30 minutes just watching without evaluating output? Doesn't the business model actively punish this kind of observation?
It creates immense tension, absolutely.
Yeah.
When the algorithm is timing your bathroom breaks, a manager standing still with a clipboard feels like a luxury the system won't permit.
Right.
But it is essential to explicitly state the limitation of this diagnostic. Observation does not establish causation.
Okay.
Counting recoveries reveals where the system is dependent on human intervention, but it does not prove why that dependence exists. It only points you toward where further investigation is required.
Oh, I see.
If a manager can't carve out 30 minutes to understand why their best worker is sweating twice as hard as they should be, the algorithm isn't optimizing the warehouse. It's just accelerating its eventual breakdown.
That's a chilling way to put it,
Yeah.
but it makes sense. Observation itself carries a massive risk, though.
Yeah.
This brings us back to work is disclosed versus work is done.
Yes, the Hawthorne effect of sorts.
Right. If an operator knows they are using an unofficial workaround, maybe one that technically violates a minor safety policy just to save time and hit those algorithmic targets, how do we observe them without them clamming up?
Yeah.
How do we prevent them from just giving us the textbook version of the job while management is watching?
That is the crux of the issue, and it hinges entirely on psychological safety.
Right.
If the organizational culture is punitive, if the response to discovering a workaround is to discipline the operator for breaking a rule, then work as disclosed will never match work as done.
They'll just hide it.
The information flow will stop immediately. They will hide the very adaptations that are literally keeping the company afloat.
You know, look at how Pixar handled the Toy Story 2 crisis with their brain trust.
Oh, great example.
They faced a massive creative and operational disaster. The film wasn't working, the schedules were entirely impossible.
Right.
But because they had built a culture where directors and staff could candidly discuss unrealistic schedules, technical failures, and communication breakdowns without fear of reprisal, they were able to fundamentally redesign their production processes.
Yeah, that safety to disclose the real work, the messy adaptations, that allowed them to actually fix the system.
Right.
To capture accurate data during a recovery load review, the culture must separate accountability for willful negligence from the learning-oriented investigation of honest adaptations made under pressure.
That's a really important line to draw.
It is. When you identify a recurring recovery, the escalation must go toward reviewing the process, not punishing or even individually recognizing the person.
Right. Let's elevate this to the strategic level, the boardroom implication.
Let's do it.
We are really talking about the tension between operator capability and process capability.
Yes.
And returning to our gyrus, it is the tension between single-loop learning, the silent workaround, and double-loop learning, which is questioning the underlying system that made the workaround necessary in the first place.
And we can see this tension clearly by looking at the principles behind Toyota's famous and-on cord, or the concept of poka-yoke.
A poka-yoke is the method of creating a deliberate blockage that prevents a defective product from moving forward.
Right.
But why does a physical blockage change human behavior? Well, by physically preventing the defective part from moving down the line, the system removes the operator's ability to silently fix it.
It forces the issue.
It forces the friction out of the shadows and into the open. It takes the burden of the workaround off the individual and makes it a highly visible systemic crisis.
The underlying goal is to force second-order problem solving.
Right.
When workers are prevented from using workarounds, they are forced to speak up and suggest structural improvements. But there is a massive, dangerous caveat to this.
And Anita Tucker, research from Harvard Business School, provides a brilliant laboratory look at this caveat.
Yes, the hospital study.
They simulated medication administration in a hospital setting to see what happens when you institute these blockages. And what they found was, if a blockage is instituted without a support person readily available to help solve the problem, the results are catastrophic.
Because the operators still face production pressure.
Right.
The nurse still has a patient who urgently needs medication. If the system blocks their standard workaround and no help is coming, they don't just give up. They invent what the study calls risky workarounds.
Risky workarounds. To put this in perspective, imagine a nurse encounters a barcode scanner failure. The system demands a scan to release the medication. Instead of waiting 45 minutes for IT, which means the patient misses a critical dose,
Yeah.
they bypass the scanner.
Right. That S first-order problem solving.
They get the job done, but the scanner stays broken. Now, if the hospital administrators decide to remove the workaround by forcing a hard stop in the software, no scan, absolutely no meds, but they don't fix the IT response time, the nurse is trapped.
Completely trapped.
To get the patient their medication, the nurse might borrow a different patient's pre-scanned medication or find an override code that disables all dosage warnings entirely.
They violate policy in more extreme ways just to maintain the flow of work.
Yeah.
In that laboratory setting, a difficult blockage without problem-solving support actually led to a risky workaround associated with a massive overdose of insulin.
Oh my God.
It highlights the ultimate takeaway for leadership. You cannot just lock down the system and remove the duct tape without providing structural support.
It is the difference between having a world-class paramedic on staff versus just fixing the staircase that everyone keeps falling down.
Exactly.
We absolutely want the paramedic. Their expertise is invaluable, but we shouldn't rely on them as our primary safety strategy for navigating the building.
No, you fix the stairs. The goal of recognizing this invisible economy is not to remove your dependence on exceptional people. It is not to eliminate expertise.
Right.
The goal is to understand that dependence. Crucially, celebrating heroic recoveries, publicly praising the paramedic for another amazing rescue at the bottom of the stairs, that actually disincentivizes fixing the staircase.
It really does.
It signals to the organization that heroism and workarounds are the desired state.
Leadership must shift their focus from praising the workaround to fixing the system. A strong operator can always compensate for a weak process, but a truly strong process reduces the need for them to constantly act as a rescuer, freeing their expertise for higher-level challenges.
And this becomes an existential threat when we consider the demographic reality of the current workforce.
Exactly. We're looking at a generational loss of unwritten knowledge.
Huge loss.
As a massive wave of highly experienced operators retire over the next decade, they aren't just taking their pensions, they are taking the invisible economy with them. They are taking the undocumented workarounds, the manual corrections, and the memory of how to bypass the broken scanner. When the new operators step in, armed only with the flawed work-as-imagined manuals, the fragility of these systems is going to be exposed overnight.
It's going to be a shock to the system.
If your most experienced operator took leave tomorrow,
Which process would worry you the most?